All right. This is now 7.5. You have a quiz, not tomorrow, because you should be watching this the night before, but you have a quiz Friday, I believe, this week, if this is 2013. If it's not, then who knows? So, anyway, you guys are going to be graphing square root and cube root functions. So let's just quick sketch some of these. Some of these you guys should know already. Y equals x squared. Well, if I have an axis, that's a parabola with a vertex at 0. So that's y equals x squared. Y equals x cubed. Okay? A cube root means it goes down then to up. So this looks like that. Okay? Absolute value, you guys should be able to do. That's the v one. Starting, this one's vertex at 0 with a slope of 1. Square root of x. Now, notice how it only says square root of x. It doesn't say plus or minus. If it said plus or minus, then you have both parts. But it only has the plus, because that's implied, that's in front. There's no negative part. So the square root of x is just the half of a parabola that's tilted. We did that on the last lesson, where we drew the full parabola when we were drawing the inverse. But this one it's asking for just half the parabola. Now, for cube root of x, though, because you can take the cube root of both positive and negative values, there's way more to that graph. It looks more like this, like 2 halves of a parabola going left and right. So, those are the graphs that you guys should be familiar with. The cube root is new, kind of. Just a real reminder, let's go back up to, well, you don't have to go back up, I guess, because you have the piece of paper in front of you. Y equals x cubed. If I wanted to draw y equals negative x cubed, all that does is it flips it over the y-axis and makes it come from the top and then go down. So that's this one. And then the same thing happens with negative cube root of x. So, anyway, let's review some shifting. Okay, review. F of x is equal to a times absolute value of x minus h plus k. So, my example I have here is this. We talked about wide and narrow, but we want to talk about stretching. Because when it stretched it vertically, that made it more narrow. So when the number was bigger than 1, this is a stretch vertically. And we will only really be dealing with stretching vertically, not horizontally today. Or I think ever. So this flips the graph, the negative, and then this makes the vertex at negative 2, 2. So negative 2, 2 is here. My graph is flipped, and now the slope is 2 over 1. So 1, 2, 1. So notice how it's more narrow than you would be used to seeing. So here's my graph. If it was just x or a 1, then it would be more. It would be we call that normal. But we will say that that stretches it vertically. Because think about it, it's pulling the graph downward. So if it's pulling it downward, the original graph downward, it's making it more narrow. So let's, given this function, square root of x, predict what happens with this. Well, first of all, this is kind of like the absolute value. Where do you think the vertex shifts to? Probably a positive 2 and a positive 3. So I'm going to start at the point 2, 3. And then this 2 stretches it vertically. This is the one people have problems with. Stretching it vertically pulls it upward more. So I'm going to exaggerate this. Instead of going normal, it's going to go like that more and stretch more vertically. So we would say this stretches a factor of 2. Alright, so let's do some more. Given this graph right here, predict what happens when I have a negative x plus 4 minus 2. Well, this point here on a cubed root is going to be at negative 4, negative 2. That's the point here where 0, 0 used to be. So negative 4, negative 2. Oh, I left the lines there, so I kind of gave you guys a hint there. The other thing that happens is the graph is flipped, so that means it goes down at the end. And it's 1/2, which means that it's being smushed together. or pushed or compressed. Okay, so this is being compressed. So instead of making it larger, it's going to be narrow. And the reason why it's narrow, this is why we can't think in terms of narrow and wide anymore, because this graph is flipped over from those graphs before. It's now going left and right. So where a 1/2 would make it wider before because you're compressing it down, here it's making it narrow because it's smushing the graph down. So what this looks like is something like that. It smushed it down more. So this is compressed. You can just say factor of 1/2, even though technically that works fine, yeah. So we'll say it's compressed by a factor of 1/2. Alright, so let's predict some more. I have an absolute value. The vertex is at 5,4, which is right here. And this is pulled up by a factor of 3, so the slope is now 3. And it's facing up. So this looks like this. And again, this is stretched upward. Okay. Now, this one says predict f of x. So we have a square root. The vertex shifts to -3, -2, -3, -2. It's flipped over and it's compressed. So it's wider. It's pushed down. So this will look something like this. You know, you don't have to be exact by it. We're just kind of sketching what it'll look like. So this is compressed. So when you compress something vertically like that, when you're pushing down, it opens it up. Okay? Alright, so let's look at graphing and determining domain and range. So this is a negative square root. The starting point is at 2, 1, right there. It flips over and it's stretched by a factor of 3, which means it's pulled downward. So it's more like this instead of the original curve. So let's determine the domain and range for this function then, just looking at it. X's start at 2, so x can be greater than or equal to 2. And my range looks like we only get y values that are less than or equal to 1, because we get 1, 0, -1 all the way off forever. Okay. Now with cube roots, the vertex point moved to -2, -1. Remember, the x one's always the opposite sign, so we're right here. It's being pulled up, stretched, kind of like this one, by a factor of 2. So it's being pulled up and down more. When you're graphing these guys, I would like you to put the points on, just so I know exactly where that point is. Okay, for the middle point. And then the domain and range for cube root functions, you should see that they are both all real numbers, because it doesn't matter with odd roots. You can have negatives and positives. I don't know why I keep drawing my R's like that. Make sure you say y is all real numbers too. There we go. Alright, so again, it's just quick sketching. You should be very familiar with those graphs. Make sure you guys just practice those cube root ones. And we'll talk more about compressing versus stretching in class, because I know that's the most difficult thing. Alright.